Hello everyone, welcome to my YouTube channel. Alright, so in this video we're going to see examples on derivatives of trigonometric functions. So beginning with the first one here, please, if today is your first time of coming to our YouTube channel, kindly subscribe to our YouTube channel. Thank you. Alright, so here says we should differentiate the following functions. The first one here, we are given y as equal to cos x minus x sine x. So all you need to do now is to begin to apply the basic rules we have looked at, the product rule, the constant rule, whatever rule, quotient rule that applies to any function you are given. Alright, so like here now we have a product here. So that means we are going to apply the product rule at that point. So let's begin. So our dy dx is going to be equal to, we will differentiate this, and if we do that, we said that the derivative of cos x is minus sine x, and now on coming to this one is a product, and so we have our minus, and then then we open a bracket, and in that bracket, to differentiate this, we are going to treat it as a product, and this will be our u, and sine x will be our v. Remember the formula for product: u dv plus v du. Okay, so we bring down our u, which is x, differentiate v, which is cos x, then plus we bring down our v now, which is sine x, differentiate u, which is x, and when we differentiate u, x will get 1. Okay, so what do we do now? We try to simplify what we have. Minus sine x, then if we open this bracket, we'll have minus x cos x. Sine x times 1 is sine x, and if we multiply by minus, we'll still have minus sine x. And so bringing together what we have here, our solution is minus 2 sine x, that's adding this and this, then minus x cos x, and that is the solution for example 1. Okay, we move over to example 2 solution. So here you can see we have a quotient. So we start by using our quotient rule, and we remember that our dy dx here is actually given as a v du minus u dv all over v squared. Alright, so what can we do here? So we are beginning with our v, which is the denominator, cos x plus sine x, now is multiplying du, and what is our u? Sine x, and when you differentiate sine x, you get cos x. Alright, so that is minus, then our u, you bring it down, sine x into bracket, you differentiate the denominator. So when you differentiate this, you are going to get minus sine x, and when you differentiate sine x, you get plus cos x. Alright, so this is all over. The denominator now will be cos x plus sine x all squared. That's v squared. And when we open the bracket, what are we going to have? Cos x times cos s is cos squared x. Cos x times this will give us plus sine x cos x. Now over here you will have plus sine squared x, then minus sine x times this will give us minus sine x cos x all over. Okay, so here we check, is there anything we can cancel? Yes, of course. From here we can see quickly that sine x cos x can cancel sine x cos x here, and we now have cos squared x plus sine x squared, which we said is actually equal to 1. So we are going to get 1 all over, and that is the solution for the derivative we are looking for. Alright, so we go to the next example. This example is also a quotient, and so we're also going to apply the same approach of quotient. And so here our dy dx is equal to, recall your v du, our v in this case is 3 plus 2 cos theta, then multiply by du. Our du is the derivative of this, which is cos theta, then minus our u, which is sine theta, multiplied by the derivative of the denominator. If you differentiate this, is 0. If you differentiate 2 cos theta, remember that we said that when you differentiate, in this case you are differentiating with respect to theta, sorry. So you are differentiating 2 cos theta. So what will happen here? This is actually the same thing as 2 coming out, and then you have cos theta here. So all we need to do is just differentiate cos theta and multiply by 2. And when we differentiate cos theta, that's minus sine theta when you multiply by 2. So you have minus 2 sine theta. The square of the denominator, which is 3 plus cos theta, 3 plus 2 cos theta all squared. And so that's going to give us, we open the bracket, we'll have 3 cos theta. This will multiply this to give us 2 cos squared theta, and we come over here. This multiply this will also give us plus 2 sine squared theta. This is all over 3 plus 2 cos theta all squared. All right, so at this point, what can we do? We factorize 2 out here, and if we do that, we are going to have 3 cos theta. Now if we bring out 2 here, we are going to have cos squared theta plus sine squared theta. Why are we doing that? Because we know this is equal to 1 all over 3 plus 2 cos theta all squared. And so if we call this 1 now, it means that our dy d theta is simply equal to 3 cos theta plus 2 times 1 here will give us 2 all over, and because there is nothing that can cancel out here, so this becomes our solution. All right, so and that's how to really handle problems involving trig functions.
Thanks for checking out Maths Experience with Precious Ugwezi on YouTube. Please be sure to subscribe and like our videos for updates.